All right. Good morning, Algebra 2 students. This week we're going to be working on lesson 8.5, section 8.5, adding, subtracting rational expressions. We're just going to do the day one notes this week, and then next week we'll get into day two notes. The notes for this week you can see here. They get pretty intense pretty quick for the day one worksheet that I asked you guys to look at on Google Classroom. So we are going to look at a couple problems on the next page. So if you flip the page, we are going to look at example 1 and example 2. Before we do that, we're going to do some additional notes. So you guys might want to copy these down. This would be very similar to numbers 1 through 3 off of your worksheet, 8.5 day 1. So if you're looking at these type of problems, they have a common denominator already. So what we'd have to do to subtract these is we would take 4 and then we'd minus that whole second denominator of 3x plus 6 all over the same denominator of 2x plus 1. Obviously, when we subtract, okay, we're going to have to distribute that negative. So we get 4 minus 3x minus 6 over 2x plus 1. And then obviously, lastly, combining like terms, we have 4 minus 6. So I'm going to put that negative 3x first. So negative 3x and then minus 2 all over 2x plus 1. That would be our final answer for that problem using like denominators. Another one we're using like denominators. Again, I made this one up. This is not in your notes. You might want to copy this down. You have a like denominator of 10x, but now we're going to add. So we have like denominator of 10x, and then I have 5 plus x squared plus 4. Now, probably most of us can do that in our head because we're adding. We don't have to distribute anything. So I have 5 and 4. Again, I'm going to put my x squared term first. I'm going to have x squared plus 5 and 4 be 9 all over 10x. And obviously, we all know that we can't cancel those x's and x squared and x's because whatever we do to one term, we got to do to every term. Okay. Next thing we'll be doing would be looking for the least common denominator. These are a little bit more challenging. This is going to be like numbers 4 through 9 off your worksheet on section 8.5 day 1. So we are going to do a couple of these off your notes, but I did create a couple new ones for you as well that you might want to jot down. So if we're looking at these two rational expressions, obviously they don't have like denominators. But they both have an x. So obviously my denominator is going to have an x, and then one of them has a 5, so the other one would have to have a 5 as well. So 5x would be the least common denominator. Okay. We could then even go further. If it just wants you to find the least common denominator, that would be your final answer. But if they wanted you to make two new fractions, then what we'd have to do is we'd go back up to the original problem and ask ourselves, well, what did we do different between 5x and 5x? Well, we didn't do anything different, did we? So I'd still have a 6 there, so I'd bring that 6 down. And then what did I do different to go from x to 5x? Well, obviously I took that times a 5. So whatever I do to the denominator, I do to the numerator. So then instead of bringing that 7 down, we'd bring down a 35. And then again, we really don't have an operation, so we would just have 6 over 5x and 35 over 5x. Okay. Another example would be if I had 3 over x plus 3 and 4 over x minus 1. Now these are considered binomials. We've done this before. So for a least common denominator, I would have to have both those binomials represented. So I'd have to have x plus 3, and then I'd also have to have x minus 1 represented for that like least common denominator. Okay. And then again, we could go through the same process if we wanted to. To go from x plus 3 to this new denominator, I took it times x minus 1. And to go from 4 to my new denominator, I took this times x plus 3. And then I could get two new numerators. Okay. Again, we're not doing that this week. And the last one, definitely a little bit trickier. You notice I have x squared minus 1, I have x plus 1. Okay, so x squared minus 1, I could actually factor that. I could factor that into be x minus 1 and x plus 1. And then you can see, hey, they share something. They share an x plus 1. Okay, but also this first rational expression has to have an x minus 1 represented. So that would be my least common denominator. And again, I could go through the same process. Nothing's different, so I bring that 6 down. The difference between x plus 1 and my new LCD would be the x minus